Hi everyone, welcome back to Dave's Math channel. This is my continuing feature on the Math Lovers book, and I'm on section 5.6 of volume 1, which is on cardinal numbers of sets, both finite and infinite. And this is going to be my third lesson on this section. The first lesson I talked about cardinality of finite sets, which isn't very exciting. Just the number of elements of finite sets. And yesterday I did a lecture on cardinality of infinite sets, and I think we saw that they behave very counterintuitively. One really interesting kind of thought experiment that this very famous mathematician named David Hilbert came up with around the turn of the 20th century is this construction called Hilbert's Hotel. And it really gets to the heart of what's going on with infinite cardinal numbers and how they behave very counterintuitively. So anyway, let's begin. And this is what I say in my book about Hilbert's Hotel. And since they say a picture's worth 1,000 words, I'm just going to skip to a couple pictures. These aren't in my book, but here's kind of a diagram of it. You're supposed to imagine that Hilbert's Hotel is an infinite hotel. It's a hotel with infinitely many rooms, specifically a countable infinite number of infinite rooms. So you can imagine that every room in this hotel has a number on it, like they do in every hotel. And the rooms are numbered 1, 2, 3, and so on, all the natural numbers. But they go to infinity. So here's where this seems like a paradox. Imagine that Hilbert's Hotel is completely booked. I guess it's the height of the tourist season, and a lot of people are traveling, so they all go to Hilbert's Hotel. It's a nice hotel, and it's completely booked. But now imagine you want to go to Hilbert's Hotel and get a room. Well, you might think like any other hotel where all the rooms are booked, you can't get in. There's no vacancy. Actually, it turns out that you can make that they can make a vacancy for you at Hilbert's Hotel, and here's how they do it. The bellhop tells you no problem. You want to check in at Hilbert's Hotel. You can have room 1. I'll move the guest in room 1 to room 2. I'll move the guest in room 2 to room 3. The guest in room 3 to room 4, and so on. I'll just move guest N to room N plus 1, and that will leave a vacancy in room 1, which you can have. So that's how you can get into Hilbert's Hotel. Pretty amazing. And pretty counterintuitive. This is just another way of saying what I said yesterday, that aleph null plus 1 is equal to aleph null. Because really what we're doing here is we're doing a bijection from the natural numbers 1, 2, 3, so on, to the natural numbers plus 1, 2, 3, 4, so on. And then we're just adding 1. But you can do even better. Suppose infinitely many guests come to Hilbert Hotel. Like I said, it's the height of the tourist season, and not just you, but there's a lot of travelers out and about. As a matter of fact, there's infinitely many. So not just one guest tries to get in a Hilbert Hotel, but infinitely many do. And can you still accommodate an infinite number of additional guests? Well, it turns out you can. As long as it's a countable infinity, you just give all the new guests an odd number room. The bellhop will say, "Oh, no problem. I'll move the guest in room 1 to room 2. I'll move the guest in room 2 to room 4. I'll move the guest in room 3 to room 6, so on. In general, I'll move the guest in room N to room 2N, where N is an arbitrary counting number. So that'll leave all the odd number rooms vacant, and now all the infinitely many guests who want to check in can go into an odd number room." Pretty amazing. So that then this is kind of shows you how the natural numbers are bijectively equivalent to the even numbers, and then you still accommodate the odd numbers. So I think it's a very clever construction, and it kind of gets at the heart of a lot of the seeming paradoxes associated with infinity. Obviously, you can never have an infinite hotel, so this wouldn't happen in real life, but I still think it's an amusing exercise. So anyway, that completes my video for today on Hilbert's Hotel. Thank you for watching. Long live math, and I'll see you guys next time. Bye.